Hey, everybody, and welcome to another episode of Today in Space. This is actually an episode we recorded, I believe it might have been on the day of Halloween. We had some time, but then didn't have any time to edit it. So here it is. We're talking about 3D printing and 3D scanning and all that stuff. And we were able to basically reconstruct a pumpkin and 3D print it, which was sick. So we'll talk about that later in the episode. But as always, we just wanted to say thank you for all your support. We're reaching more and more people. People are finding out about the podcast, and you guys are reaching out and saying some great things. So we really do appreciate it. It's kind of crazy to think about that we've been doing this for, almost a decade, talking about space. And one of the questions I get a lot is, how do you come up with all of these ideas? And honestly, I don't know. I think when you're really passionate about something, it's just an infinite well that you can tap into. So for me, it's space and science and 3D printing, which is this episode. The streams are crossing, so it is great. But a lot of it is about that flow state. It is about getting into that state where you just let ideas flow. And for me, this started off. The reason I'm even podcasting is really because I got into jazz and into music and performing, and this was kind of my way after college to get back into that. But I've tried many, many different ways of trying to access the flow state and be creative. And while there's a lot that's involved, I want to say Magic Mind Productivity Shot is without a doubt such an easy way to prime yourself not only into a flow state, but for me, it's actually going to be a much bigger part of my stress management. The last episode, The Human Factor, we talked about my kind of wellness journey and caffeine and, how Magic Mind is helping to start reduce how much caffeine I have because I drink a lot of it. It can be really hard, especially if you're someone like me. Like, people always ask, how do you do this? How do you find the time to do this podcast? It's about carving the time to do that, really, at the end of the day. Like, it's always tough to find it if you don't make time for it. But once you make time for it, it's just about showing up. And that's one of the great things about Magic Mind is it's helping me show up when I have that time. It's not a lot, maybe an hour or two, maybe max on like a weekday after work. That's on a good day. So you've got to be efficient. You got to jump in and do what you got to do. And Magic Mind is doing that for me. So if you want to check it out, go to magicmind.com. Use the code word todayinspace20. That gets you 20% off the order. Now, I just had to re-up. I just went a week without Magic Mind because I messed up the timing of the order and stuff like that. That's on me. But here's the thing, and I even get to do this too. So jump on the bandwagon if you want to with me here. If you're looking to decrease caffeine in your life, prime yourself like that little gas pump they used to have on like the lawn mowers or the snow blowers. I don't know if anyone remembers that, but you'd literally prime the engine with fuel before you would pull the ripcord to turn it on. I don't know why I went down this road, but it is a great primer for you. If you get the subscription package, right? I went with the 30, so I've got a whole month's worth supply. If you go with the 30 count productivity shot, you get a discount. Then you tack on Today in Space 20. That's another 20%, which means you're at 56%. You drop the price below $3 a day. And for me, I have been trying to get kind of all of these supplements that are in here. Phosphatidylserine, lion's mane mushroom, Bacopa monnieri, cytocholine, ceremonial matcha, which you'd think it would taste bad, but not with the shot, especially if you chill it beforehand. It's glorious. Cordyceps mushrooms, rhodiola rosea, B2, B3, B12 vitamins, ashwagandha, L-theanine, and turmeric. All of these things in a shot, $276 per bottle if you use the code and combine with the subscription package. It's under $100 for a whole month's worth of goodness. And if we're trying to become better human beings, this is what it's all about, right? So anyways, I've gone on long enough. Magicmind.com/todayinspace, code word todayinspace20. And let's dive in. This week we have a 3D printing episode. More on that soon. So thanks for joining us. This is Today in Space. Hello and welcome to Today in Space. On this episode, this science officer is going to show you how we used 3D scanners to 3D scan a real pumpkin and make a 3D printed pumpkin-stein. What did we do? What kind of science magic have we done? Well, this is our pumpkin that we got for Halloween that we were going to carve, and things just got busy. So now it's beautiful harvest. But one thing that you always see, especially with any kind of like food, right, is that over time it degrades. We've all seen the pumpkins that stay on the stoop a little bit too long and just extend the Halloween horror as they start to break down. But what I wanted to do was 3D scan this and see if I could print it and see how good the scanner is and how close to reality we could get. And I'm going to tell you, this was pretty awesome to go from scanning this. It took me like a slow hour to get the final scan. But honestly, once I knew the right approach to use this scanner, which we'll talk about in a second here, it was like 25 minutes. So from 25 minutes of scanning and prepping all the file stuff, just making it a good model, right? And putting it on our 3D printer, overnight this thing printed. And here it is, a digital capture of this pumpkin at a very specific time. It has some of the grooves that the pumpkin itself has. I mean, if you look at this area, it's really crazy what this scanner picked up. So kind of like the philosophical question is this like real? Like, what is this 3D model of this pumpkin? Is it a real pumpkin? What does it capture? What is it telling us about this pumpkin and all that stuff? So that's for later, but let's just start with some of the basics of how we got here. So we've been using 3D scanners for a long time. Some of my STEM journey, even some of this is documented in old episodes when I'm talking about working the second shift. That's my time in the 3D scanning world. And it's come a long way in such a short amount of time. The same can be said about the 3D printing world. The changes that it's going to make in the next 5 to 10 years, especially when 3D scanning, 3D printing starts getting on to spacecraft and we start spending more time as humans in space, this is going to become an extremely valuable tool for people off planet to make and use and adjust anytime when they're elsewhere. We'll just spend the payload space for a spacecraft that we're sending stuff to Mars, let's say, or even the moon in the next few years, or decades, I should say. We'll just be able to send the material, and then you can make whatever you need to over there. You could even have a system where, once you've used parts or maybe they've broken, you grind that material back down into pellets to be used again and recycle that material to make new things. So there's a huge, in our opinion in the podcast, a huge opportunity in space. Once we start getting people living in space, 3D printing, in our opinion, is going to be a huge piece of that puzzle of staying alive and really thriving in an environment where we're just only starting to explore. So 3D scanning, my journey started when I was working in metrology. It was one of my first engineering jobs out of school. Metrology is the science of measuring. One of the things that's kind of crazy that you learn when you do metrology or get into this kind of science, you realize that there is like a kilogram, right? They have something that is measured, and that is what we like scale everything to for that constant of that mass. But if you measured it around the planet, around Earth, you would notice that it measures slightly different. And I know we've started to do some tests of when we see gravitational waves and different disturbances that do happen to come through Earth, that there is like minute differences in the measurements. But we make a constant because it's easier to do things. But what is 1 kilogram technically is looked at every single year and updated if needed, which is kind of crazy. So when I was working on these things, I was a field technician, so I would go out to sites, I would bring this laser scanner, and there would be this little eyepiece, so you'd have to catch the laser, and then you'd move it around, and then this ball became your measurement point, and you would put it against the surface of the thing you were measuring. We could do huge, large things, and extremely tiny things. We could do measurements with a different machine. And I helped manage that lab, and I learned a lot about 3D scanning, and I saw the potential, but the price point was way out of anybody's reach, especially for a very good scanner that I could say, let's take this thing, scan it, and 3D print it. First of all, the price wasn't there. Back in the day, we're talking, this is 10 years ago, right? So $10,000 and up just for like a basic one of these scanners or equipment that could measure things. And that's just the scanner. That doesn't include the software, which probably is double that. And so you're looking at like 10 grand at least just to get into this, and then think about all the jobs you'd have to do to make that back and then eventually make profit. It's a crazy business. So these folks were doing a great job, and really top of metrology, especially in the East Coast here in America, but across the country as well. Then there were some 3D scanners that started popping up in the maker world. There were things like the Xbox Kinect, which was actually being used as a scanner. It wasn't great, but honestly, for the time, it captured a real enough general shape. Like you could scan a person's body and try and do some other things, but you weren't going to do anything, I wasn't going to make like a replacement part for somebody, right? You've got like an oven with an old knob that's not, they don't sell it anymore, or any of that stuff. Like you couldn't just 3D scan something with one of these Xbox Kinects, but it was a really cool start. And I got one to try and play around with. The software was a bit of a nightmare, and I never really got it up and running. And then eventually, a few years later, I'm out of 3D scanning and I'm in 3D printing. And this Pop 1 scanner comes up from RevoPoint. And so this scanner was, I think it was like $750. And it came with a software that did the scanning and the point manipulation. For me, getting one of these, and I think I got in on an early thing, so it might have been like $500. But my plan was for AG3D, our lab, was get this scanner. We could scan people like full bodies. We could do cosplay armor, and hopefully do like reverse engineering and help people make parts that maybe have broken and aren't made anymore, or replicas, whatever you wanted. We could have that possibility. And the scanner was okay. The tolerance, the accuracy of the model that you would get was enough for scanning a body and a person, right? You could get like a general shape. You could scan some things that were larger than your fist. But again, the quality wasn't quite there. And the software itself in the beginning struggled. It's come a long way, and I still use that scanner with some of the new software. But again, it just hadn't quite gotten there. And that's very telling for tech, right? In a lot of different ways. But then this Inspire scanner came up very recently. And, it was a bit risky. It was a Kickstarter. They basically had these ready, but they were doing a Kickstarter to give people 30% off on Kickstarter. So I did do that. I think I got this for $220. And the tolerance here is 0.2 millimeters. And I'll look what that is in inches for all the Americans who don't want to do the conversion, which I understand. I do it because millimeters are way better for engineering stuff, and also all the 3D printers are in millimeters. So we're talking about 0.008 inches of accuracy, of tolerance for the model. And you can see that here in this model. And one of the things that is really cool is that this now engineering, as they call it, grade scanner, opens up the possibility that you can capture a 3D model that's more accurate than the machine, the 3D printer, that you're going to print on. Because our 3D printers have an accuracy, a tolerance of 0.5 millimeters. So more than double the quality from the scanner, and you can just see how much that's changed things. And the software itself has gotten so much better. It's come leaps away. So Riva Point's really done a good job. I'm not sponsored by them. I'm a customer. But as someone who's out there doing the maker thing and, you know, trying to bring things into reality, there's a lot of things that we've done over the years before technology has kind of caught up. You know, with a set of calipers, these guys right here. So a set of calipers, if you've never seen those before, you can measure the outside of things between here, and you can measure the inside of things with this. People will also use it as like a drop gauge, so you know you can have a height and drop this down to whatever you need. I don't have a digital scale. A lot of them today will have a digital scale. I recommend this. This was just a way for me to catch up on my math skills and use the dials that back in the day, especially like Apollo era, they had these. Those brilliant engineers were doing most of that in their math, most of that math in their head. And tools like this were helping them do that. So all in all, I've taken a lot of what I've learned over the years, the different skills, the different jobs I've picked up, and I've stacked them in a way that allows me to use those skills. And it's not just a wasted time on something I'll never do again, which for me was what school felt like a lot. And with 3D printing, I'm able to go from this thing in my head, you know, from, hey, I've got this pumpkin, let me see if I can scan this. And now we have captured this pumpkin in a certain point of its lifetime, right? Because it's on its way out. We'll see if we can carve it in time. This pumpkin now, this shape is something we can print every single year. We can carve out eyes on this pumpkin. We can make this really whatever we want. We can make it a light now. We can now take this model and do what we want with it. And this real thing, this real pumpkin, is now digitized potentially forever in this 3D model. And I think I'm going to make this available online. So other people will be able to have this pumpkin shape in front of them and print it, which is very similar to what's happened in space. And one of the famous 3D printing examples of space is Butch Wilmore on the ISS making the 3D printed wrench. We have one here that is a representation of that. But that wrench was sent up to space digitally. It was then printed in space, brought back, and they did a whole bunch of tests of what this 3D printed material did in orbit versus in 0G versus back on Earth. They found a lot of different things. The tensile properties were slightly different, better in some areas, more brittle in some areas, but the layer-to-layer bonding was better. And so there's all these different things that we can use 3D printing for. For us, we're very excited to see and potentially be a part of the 3D printing future in space and how we use that in missions, in sight to, using the resources that are available to you, and also being resourceful and recycling the material that you send there to use through a 3D printer, a filament-based 3D printer like this one. So there are different tools out there, even for folks like you, if on a budget. There are 3D scanners that are well below $500. You could pick up a 3D printer like this one and a 3D scanner for under $500 if you were really good about it. And you maybe found one on eBay. You went with like a baseline 3D printer. Under $500, you could bring things into reality in an extremely high quality way. So it was a fun project, a really quick thing for me to do, and obviously a fun Halloween-based thing that we wanted to bring to you. It's a short episode, but there's, in the world that seems so crazy, there are a lot of amazing things out there if you look for them. And obviously, I'm not saying that there are plenty of problems. There are plenty of problems in the world that we need to solve, but we also need something to look forward to and things that can make the world better. And I truly do believe that 3D printing has that ability if we get this into the right hands. So I'm here to show you what's possible. I've been doing this for many, many years, and it's become my day job as well. So 3D printing really can change the world, and we're excited to show you more of the ways that it can do that. But that's it for this episode. Thank you for joining us. And what we want to do is ask you before we leave, what is this? What is this 3D printed part? Is it the real pumpkin? Is it just a piece of something, and it looks like a pumpkin, but it isn't a pumpkin? I mean, what does the quality of the captures of all the imperfectness of the surface, these little bumps and scratches from just life in the ground growing, right? Or is it something more? Is it some kind of capture of time of a real thing, almost like a memory that then anyone can have in front of them? That 3D printed wrench in space, is it special? Is the one that came back special? Is the file special? Is the 3D printer special? These are the kind of things I'm wondering from you. The big question of the day: if we 3D print something, is it real? Just like the replicator in Star Trek, is what comes out of that real? Is the Earl Grey hot that Captain Picard is drinking out of the replicator, is that real Earl Grey tea? These are the philosophical questions we're going to ask ourselves in the near future, and we're here to bring it up today before tomorrow becomes our reality. So thank you for joining us. Happy Halloween, and we'll see you on the next episode of Today in Space.